Okay, so for 7.3, we're going to look at adding and subtracting rational expressions. We're going to start with just looking at monomial denominators. So if you recall correctly from our beginning of the unit where we talked about fractions, when we talked about adding and subtracting fractions specifically, we needed that common denominator. We needed to have something in the bottom that matched on both fractions. Okay, and we accomplish this by doing a multiply or divide by one idea. And so that creates our common denominator. We're going to call it the LCD because we're going to go shoot for the lowest common denominator, because then we have less reducing to do at the end of the question. To find the lowest common denominator, it needs to contain the greatest number of any factor in the denominator of either fraction or rational expression. If it appears in both expressions, you must include it only once for each time that it appears in both. Okay, so once both numbers or expressions have the same denominator, then we can do our adding and subtracting just like we would do with our fractions, and this is only done on the numerator, and the denominator doesn't change after that part. So example 1 is just looking for our lowest common denominator. Now, before we actually tackle this one, we can look at a kind of side example where if we think about 2/5 and we're adding that with, or maybe let's do 2/15 and I'm adding that with 1/9. I'm not just going to multiply 5 times 9 or 15 times 9 to get my lowest common denominator, because they actually have something in common. They both have a 3 in there. So 15 breaks down to 5 and 3, but 9 breaks down to 3 and 3. So this guy, because it pairs up between them, only actually needs to show up in my lowest common denominator once, which means my lowest common denominator is going to be 3 to account for my pair, multiplied by 3 again for that 9, and multiplied by 5 coming from 15. So my lowest common denominator is going to be 3 times 3 is 9, times 5 is 45, which is way lower than 15 times 9. Okay, so in order to make this happen and actually achieve the lowest common denominator, so it's over 45, it would have to be 15 times 3. And so we're going to multiply numerator and denominator by 3. So 2 times 3 is 6. 9 would have to be multiplied by 5. So it's going to be plus 5. And then we could solve it from there. 11/45 would be my final answer. We need to break it down into its factors and check which factors kind of are shared. Each time it's shared, it only shows up once. So bearing that in mind, when we look at a rational expression with variables present, we need to do the same thing. So in this particular case, we have x minus 3 showing up once in both of them. So that means that I'm only going to write it once to represent both of these pieces, once from each fraction. So when I go to determine my lowest common denominator, and that's all this question's asking, it's not even asking me to finish it off, it just asks for the LCD. I'm going to do x minus 3, okay, and that takes care of my pairing. X plus 3 takes care of that, and x minus 3 again, because this one doesn't pair up. Now you could simplify that to be x minus 3 squared times x plus 3 as well. But that's how we determine our lowest common denominator. So when we look at example 2, we are going to actually complete these questions. So step 1 is factor, if possible, or if it needed. Okay. Then we're going to look for the lowest common denominator and convert. But before that, actually, even, we can state our NPVs. 3 LCD and convert. And 4 simplify. Those are our 4 kind of key steps. So in this case, for A, I check it's factored completely. I state that my non-permissible value is going to be that B can't be 0 because it's just B by itself in the denominator for both scenarios, which means that it is already my common denominator. So I don't need to change anything. I'm just going to go ahead and subtract these. Now I personally like to rewrite it. So it's 2a minus a minus 1 over b. Once I have my common denominator, I like to write it over one common denominator, just personal preference. So then this negative technically applies to both pieces. So I've got 2a minus a is a, and then subtracting -1 is the same as adding 1. If you need to take a step to actually show that, do that. And here we go. So my final answer is b cannot be equal to 0, simplified. Okay, example B. I check this is as factored as it gets. So I can state my non-permissible values as x cannot be positive 2. Again, feel free to figure that out algebraically. My lowest common denominator, luckily again, is going to be x minus 2, which means that none of these need to change. So I can go ahead and say, well, it's x squared plus 3x minus 10 all over x minus 2. From here, I do have a trinomial that can be factored. You'll see why I want to do that in a second. So that becomes x plus 5, x minus 2 divided by x minus 2. Well, those binomials were multiplying and dividing by the same binomial, so they cancel out. So my final answer is x plus 5, where x cannot be 2. Okay, so we are not done up here. If you can factor a trinomial, you always want to look to factor, because that might lead to reducing it like that question did. Example C. Again, my denominators can't be factored, so I start by looking at non-permissible values. A can't be 0, and B cannot be 0 in this case. They're just multiplying, so zeros are what's going to turn that into a problem. My lowest common denominator, I'm dealing with 5ab and 4b squared. So 5 needs to be in here, a needs to be in here, b needs to be there twice because it shows up twice in our second one. And then 4 needs to be there as well. Now we can combine our like terms in terms of multiplying. So my final answer is going to be 20ab squared. That's my lowest common denominator. So I'm going to show all my work for this one. 5ab needs to be converted to 20ab squared. So we need to multiply by 4. So 5ab needs to be multiplied by 4b to make sure that I get to achieve this. That was what's missing from our original denominator. And whenever we multiply something within an expression, we need to kind of multiply or divide by 1, so we're going to do that. My second term is 3 over 4b squared, so that's missing 5 and a. Remember, both of these times I am multiplying by 1. So what 4 times 4 is, so we've got 16b minus 15a all divided by 20ab squared. And I actually have to stop there because there's nothing in common between my two terms in the numerator. And so my final answer would be this, where a and b cannot equal 0. Okay, how are we feeling about that? Ready to try another one? Okay, recall when there's a whole number, it's like it's being over 1. Okay. These are not factorable, so my non-permissible values are going to be x cannot be 0 and y cannot be 0. My lowest common denominator needs to include 1, which just is itself. It needs to include x squared because that's the most times it shows up. And it needs to include a y. So when I go to create my common denominator and multiply by 1, my first expression, it already has an x and a y, I just need one more x. My second expression already has the whole x squared, it's just missing y. And my third term, is missing everything, so it's going to need to be multiplied by the whole lowest common denominator as 1. 2x times x is 2x squared plus 4y minus 3x squared y, all divided by x squared y. It becomes my final answer, where x and y are not 0. How are we feeling about that? And again, you can double check that these denominators all make sense. X squared y, x squared y, x squared y. Check, check, check. All lowest common denominator. Okay, so pause the video maybe and give C a shot. Just remember that when you're doing this one, it's like you're going to have to distribute to both terms within the numerator. Okay, so if you pause the video, good on you. I am going to walk you through this part. Non-permissible values, C and D cannot be 0. My lowest common denominator is going to be 15c squared d. I need the 3, I need the 5. I've got c showing up, but here it's twice, so I'm going to have 2 c's, and then d shows up once. Okay, so when I go to rewrite this, I'm going to have 3c minus 2 over 3c, all multiplied. There we go. I have 3c, I need 5cd still showing up there. Minus c plus 8 over 5c squared d. The only thing I'm missing from that one is the 3. So when I'm dealing with this part, again, I'm going to have to distribute this into both my terms. Okay, so I've got 15c squared d minus 10c d minus 3c plus 24 all over 15c squared d. Bearing that in mind, I need to actually change these signs so I can apply that negative here, and if I distribute it into the brackets, that's negative as well. If I look to simplify, I actually can't simplify this anymore, so I'm left with 15c squared d minus 10cd minus 3c minus 24 all over that 15c squared d with my non-permissible values of c and d not being able to be 0. Now, why can't I just cancel these out? The correct reason is canceling only actually represents the idea that opposite operations are occurring at the same time. So if multiplying and dividing are occurring at the same time, that allows for things to cancel out. So these two pieces are dividing by each other. They're the same exact value, so they technically could cancel out. That would defeat the purpose of what we were doing. Here, because subtraction is happening before division, we cannot account for that. This denominator applies to all 4 terms in the numerator. So we can't take it out just because it matches 1. So let's try the next one. Non-permissible values. This is already factored. It's going to be x cannot be 0. My lowest common denominator, well, remember that 8 breaks down to 2 and 4, which is actually 2 and 2. 6 breaks down to 2 and 3. So one of these 2's actually counts only once. And then each of these ones needs to count on its own. So 2 times 2 times 2 is 8. Times 3 is 24. Or you can actually write it out first. That might not be a bad thing. 2 takes care of both of those. Times 2 times 2 takes care of both of those. Times 3. And then x squared, which would be 24x squared, is what I need. So we've got 8x, so we need to multiply by 3 to get to 24, and we need to multiply by x to get x squared. For my second term, I've got 6 already, so 6 times 4 is what's going to get me to 24, so that's what I'm going to do. And then I'm also going to look at x. It's already x squared, so I'm not going to need to do anything else. So it's just 4 over 4 for that one. Sorry. So in this case, I'm going to again have to distribute through my brackets. So I'm going to end up with 3x squared minus 15x plus 4x minus 28 all over my common denominator of 24x squared. If I try and simplify that, I've got 3x squared minus 11x minus 28 all over 24x squared. I cannot factor that numerator in a way that's going to let me cancel out with this denominator at all. I can't take out a common factor, and so I'm left with this and the point that x cannot be 0. Second last example. My non-permissible values. Again, because we're only dealing with monomials, we're ending up with a cannot be 0. My lowest common denominator becomes a little bit more complicated here. I need 2 2's to make 4, and I need a 3, and I need a squared. So that's going to be 4 times 3 is 12a squared. So that's what I'm trying to make. So I've got 5 over 2 right now, so I need to multiply by 6a squared in order to make that 12a squared. Then 3 times 4a squared. I've got most of it already there. I just need to multiply by 3 to get that 12 to show up. And finally, I need to multiply by 4 to get that 12, and I need another a in the denominator here. So each one gets multiplied by something different. The reason we're allowed to do that is because each of them is technically 1. And 1 multiplied by anything is itself. So again, creating those equivalent fractions. So I've got, 30a squared minus 9 plus 8a over 12a squared. I'm going to just rewrite that so my trinomial is in order of degree. So I've got 30a squared plus 8a minus 9 all divided by 12a squared. And again, because my numerator has no greatest common factor that can be taken out that might cancel with my denominator, I'm going to leave it like this. Okay, last example, still the same principles. So my non-permissible value is that z cannot be 0. My lowest common denominator needs to include 3, needs to include a 2 from the 6, and then 2 more 2's from 8, and then z squared. Again, feel free to write these in prime factorized form if it helps, or if you can just spot it, good on you as well. And so we get 3 times 2 times 2 is 12. So we've again got 24z squared. So even though we threw that 3 into the mix, it hasn't actually changed the lowest common denominator compared to that previous example. 2z plus 1 over 8z squared. All we need to create is that 24, so 3 multiplied by 8 will get me there. 4z, put brackets around there so I remember to distribute, minus 4 over 3z. Well, 3 times 8 gets me 24. I still need another z, so that's how I create my common denominator. And finally, 8 minus z over 6. I need a lot here. I need to multiply by 4z squared to create my common denominator. Again, I have to distribute. And again, I want to point out that each fraction, each term, can get multiplied by something different because this number is just multiplying by 1. So I get 6z plus 3 plus 32z squared minus 32z minus 32z squared minus 4z cubed all over 24z squared. Okay, well, we need to simplify this. Those signs are switching out. Okay, so collecting like terms, I've only got one cubic term. So that means that I'm dealing with 4z cubed. I've got 2 squared terms, and they actually have opposite signs and equal coefficients, so they're going to cancel out. Opposite operations, right? Addition and subtraction, those are allowed to undo each other. Then I've got a negative 32z and a positive 6z, so that's going to be negative 26z. And then just my lonesome positive 3 as my constant, all over 24z squared. Now again, I have no common factors. That's the only thing I can look for in my numerator when I'm dealing with a monomial denominator. And so this is going to be my final answer, where z cannot be 0. So you've got your workbook practice to do. Give the questions that have monomial denominators a shot. If you're feeling pretty confident about this, move on to the next lesson where we look at binomial denominators.